Here we have a continuation of the logic and debate class for Christians, and we are in inductive reasoning. Inductive reasoning is the kind of reasoning that you go from a specific point and draw a general conclusion from it. Whereas deductive, you have an A-type proposition, and you look at it and you draw an I-type proposition from it. See? So you take a universal and get a specific conclusion. For deductive. Inductive, you go the other way, and since you're taking a specific point, you don't always, your conclusion is not certain. So we have different approaches to it. And so science is based upon inductive reasoning. There are 5 basic assumptions of science. This is where we got to last week. And these assumptions are that nature is understandable. And if it's not understandable, there's not much we can do about it. So we assume it's understandable, and I believe that's a good assumption. I believe since God created it, it makes sense to be understandable. All nature is subject to the same laws. There's a principle of uniformity of nature is true. Now, we're not saying the idea of the doctrine of uniformitarianism is true. Uniformitarianism is false. And because even the atheists now rejected uniformitarianism. What we're saying is the laws of nature are the same throughout the universe. And that's the assumption we're making. And so that's the uniformity of principle of uniformity of nature is true. Then the next one is measurable causes underlie observable effects. And for every effect, there is a sufficient cause. That's what we're saying. Now, then the atheists change that, and they argue that for every effect, there's a natural cause. Well, there's a natural cause for a lot of things, but there's some things, like the beginning of life, the beginning of the universe, that the atheist absolutely, his system will not explain it. And it violates the basic laws of science. Basically, we have the 2 principles, the laws of thermodynamics, first, second law, are violated by the Big Bang Theory and some of the ideas about how things began, and they get something out of nothing. Now, that's not possible. Something comes from nothing. And then, of course, life comes from non-life. That's the law of biogenesis, biology. You don't get living things from non-living things. So again, all things don't have a natural cause. Now, most things do, because God set in motion the laws of nature. But after God ordained the laws, then everything reproduces after its own kind, as we see in Genesis 1. The fourth is that the simplest explanation is probably the correct one. That's an assumption, of course. These are all assumptions. And I think that's a pretty good assumption. And so the simplest is probably the correct one. And there's chances for that being wrong, though. You have to be careful of that one. The unfamiliar is explained in terms of familiar by analogy. I'm going to get into analogies here tonight. I think I wouldn't be able to get that far. But analogies are something that's really kind of messy. And even the logicians tell us it is. Hurley, we have a quote of Hurley later where he talks about analogies and the troubles with them. They are difficult to deal with. But an analogy doesn't prove anything. And we'll look at analogies a little bit later. Now, Copy, and I quote these 3 different logicians, and I probably ought to have gotten a couple, 2 or 3 more logic books and quoted some others. But these 3 are pretty good. And I recommend that if you can get 3 books. These are good. There's another one that's really good, and I cite it also. But a great many arguments are not designed to demonstrate the truth of conclusions as following necessarily from their premises. Now, he's talking about deductive reasoning, and he's saying many arguments are not designed to demonstrate the truth of following necessarily from the conclusion. See, they're not necessary inferences. Now, the necessary inference would occur in a deductive argument. And an if-then statement, if S, then N. That's how I've set it up. If S, then N. S is sufficient, and the N is necessary. So the conclusion is necessarily follows from a sound conditional syllogism. See, that's deductive reasoning. So he's saying that many arguments are not designed to do that, but are intended to merely support their conclusions as probable or probably true. So we're showing that something is likely to happen. The degree of likelihood can vary with the amount of information or the evidence that you have. And so we'll have to develop this and expand upon it a little more. Arguments of this latter kind are generally called inductive. They're radically different from the deductive variety because they go the opposite direction. See, they go from the specific to the general, whereas we have the general going in deductive and drawing specific conclusion. All polar bears, if we say, are white animals. If we make that argument, then we say polar bear X is a white animal. See, that's going from a universal statement to a specific statement, particular statement, universal to particular. Of these non-deductive or inductive, non-deductive or inductive arguments, perhaps the type most commonly used is argument by analogy. So an analogy is a inductive argument. It's not a deductive argument. So you need to be aware of that. If you get in a debate with someone, sometimes they'll use analogies, and the analogy doesn't prove anything. And there's some problems with analogies. So we'll try to deal with some of them, but the study of analogies gets pretty complicated. How to deal with them and recognize the errors in analogies. But an analogy doesn't prove anything. Keep that in mind. It shows something that might be likely to be true. Scientists assume the principal cause and effect is valid, and it's proper in determining truth. And I believe they're good. I believe that's a good assumption. In other words, for scientific purposes, every fact is assumed to yield identical results. They assume if you repeat a laboratory exercise that it should give you the same results every time, as long as your conditions are the same. Okay. Now, keep this in mind. I'll just go off on a tangent here just for a minute. In western Oklahoma, where I grew up, they were drilling wells, gas wells, natural gas wells, down to 25 to 30,000 feet deep. And what was happening is they were running the well because the men that were completing the well, they put chemicals in the well to treat the well so it would flow. And the problem is they were putting chemicals in for a well that was maybe 5,000 feet deep or shallower. And then they were going to 20, 25, 30,000 feet down. Well, what happens is the rock gets hotter and hotter the deeper you go. And the chemicals, if you know anything about chemistry, the chemicals are going to change how they react if you change the temperature. So the temperature would make the chemicals react much more strongly, and it was messing up these wells. There's a friend of mine who had a PhD in chemistry, a master's degree in metallurgy, and a PhD in physics. He was quite a character. We grew up near one another, and he was telling me about the wells that he had completed and treated, and every well that he treated, because he knew what to do. He knew the temperatures. He knew all of this stuff, having all these degrees and backgrounds, and they were just falling all over themselves to get him to complete their wells, because every one he completed was a real good well. So again, there's different situations. The temperature can be different, barometric pressure can be different. Things like this can affect the reactions of chemicals and even other things as well. And I keep that in mind. I'm told that if you get the power lines like in Siberia, when it got around 70 below zero, that the copper wires would shatter like glass. Whenever winds got up, the wires would just shatter like glass. So that the copper, when it gets that cold, is just like brittle like glass. But I haven't verified that, but I read that in some journal somewhere that's the case. But let's look back here. Stanley, page 80, tells us this, and this is a quote of a book. But another way to put it is every house has a builder, Hebrews 3:4. Well, that's scripture. And I believe that to be true, and that's a principle there. Every house has a builder. When you see a house, you know it's something that's been designed, somebody built it. So the Lord gave the principle of cause and effect. He was speaking of a sufficient cause. Now, I'm going to give an illustration, and I footnote it down here. If I see a 20-ton truck moving up a hill with a 5-degree slope at a speed of 60 miles per hour, I know a 1-horsepower engine is not a sufficient cause to bring this effect about. Why? I'm going to go down here at the bottom and just really quickly run through it. 1 horsepower, it was designed as the energy or the power it would take to lift, the power it would take to lift 550 pounds of weight 1 foot in 1 second at sea level. So a 550-pound weight would be lifted by 1 foot. And that was a draft horse could lift a 550-pound ore bucket 1 foot and in 1 second. And so from vector analysis of this truck, he's going at an angle, and the slope he has, he's moving upward at the rate of 60 miles per hour, he's moving upward at 7.7 feet per second. And that's rounded numbers. This yields, it needs 307,960 foot-pounds per second of upward movement of the truck. So it would require a 560 horsepower engine to move that truck upward if it were 100% efficient. So a 1 horsepower engine just won't even come close to it. There's your mathematics for it right there. Now, let me say this. You can see something, and I can say a propeller-driven airplane just won't fly 2,000 miles per hour. And I think there's some reasons for it, okay? And so it's just not going to happen. Barker says, he says of this, we shall speak of inductive decrees as being probable, no matter how well established they are. They're just probably true. And the probability is different with different amounts of evidence, see. This relates to what the scientist calls empirical truth. Now, empirical truth is truth that's gained by your senses, one or more of your 5 senses, and that's empirical truth. Empiricism is the doctrine or claim that the only way we know anything is by our senses, but that's not true. We've already dealt with that. Man's knowledge of truth is discovered by the scientific method, and it is tentative knowledge because it's only probably true. And different degrees of probability, however, some things are probability is so high that we can treat it as if it is true. See? We operate upon it. I've used Bernoulli's principle, the airplane lift, the lift of an airplane wing, as a principle that is probably true, and the probability is so high that we get in an airplane, don't think anything about it, we'll fly. Even the scientist assumes now we dealt with absolute and tentative truth. He assumes that absolute truth exists when he conducts scientific experiments. And I'll show you why we can prove that. He's searching for what's absolutely true. When he claims to have discovered a law of science, he's claiming to have discovered an absolute truth, or that he likely has properly found it. And let's look at how Barker deals with this, shows an inductive generalization. Here's his inductive generalization. That is, A, B, C, and so forth, each have been observed to be S and P. Both of them, all three of them are S and P, both S and P, whatever S and P happens to be. Nothing has been observed to be S without being P. So we can't find anything that's an S that's not also a P. Probably all S are P. You see, notice the last conclusion, probably, therefore probably. So the strength of that probability is based on how much evidence that you have here. So this gets into such things. If you really get into the degree of probability, you got to get into statistics. Since conclusion is absolute, it's an A-type proposition, all S are P, then all S are P, this is claimed to be an absolute truth. So a person who is truly a scientist can't say there's no, all truth is tentative, unless he says he's claiming that there should be an absolute truth because he's looking for absolute truth. And so his claim is that there is an absolute truth. I think they get into contradicting themselves, and I think John Dewey contradicted himself because his inductive generalization was a universal proposition, all S are P. And he's just not very rational. That's the problem with John Dewey. And what he's foisted upon the American public and the Western world in general. Since conclusion is absolute, that's the claim of absolute truth. Of course, an old-type proposition would contradict this claim. So what the scientist does is he sets up an experiment and he looks for something that will contradict it to disprove it. Now, that's in theory how they operate. In practice, if you go to Appendix V, you'll see they don't always do that. And honest scientists, that's how they do it. Sometimes they're not honest. Now, we have fallacies, and the word fallacy is used for something that's not going to draw the right conclusion, and deductive reasoning and inductive arguments are affected by fallacies. Both are. But a fallacy of deductive is something that's going to be it's going to be unsound or uncogent. That is, inductive will be. So deductive will be, fallacies will be different nature. They're divided. Cogent is at the bottom of the screen is inductive, that argument that's strong and has true premises. So it's strong. Again, it's not conclusive. It shows a likelihood of something. The likelihoods may be strong enough that we operate upon as if they're true. They're usually divided into two groups according to Hurley, formal and informal. A formal fallacy is identified by inspection. That is, we could say, does it deny the antecedent or does it affirm the consequent or something to that effect? So we can see by inspecting that it's a fallacy. If you form an argument that denies the antecedent, it automatically is fallacious. All right, it proves nothing. The conclusion might be true, but it would have to be proven with another argument, see? We're not saying the conclusion is not true. We're saying you haven't proven it with an argument that denies the antecedent. Another argument may prove that conclusion. It might be true, and it might be false. We don't know from the argument that the one gives that denies the antecedent. Another argument that affirms the consequent, we would not know whether it's true or not either. because the argument doesn't tell us, because the argument is invalid. So validity relates to deductive arguments, and cogency, and I'll put my mouse on it right up here. Cogency, a cogent argument is one that is, and we'll get back to it, at the bottom it's inductive, it's strong, and has true premises. See, that's what I mean by cogent argument. So cogency is applied to inductive reasoning, and validity is applied to deductive reasoning. So that's two different ways of looking at them. In validity, you can recognize an invalid argument because you look at the form. See? But you can't do that with inductive reasoning. And so there's not a specified form for it that can be used to say that it's not valid. So we don't talk about validity with respect to them. Sometimes some fallacies are committed by people who are using induction to derive their information. There's three basic kinds of fallacies that are the main kinds, but there are other fallacies relating to inductive reasoning other than these. So the three we're going to look at, the three main mistakes here, Barker talks about them. We have forgetful induction, hasty induction, and slothful induction. I'll highlight it. Those three right there. And so forgetful induction, he tells us right down here, the first is neglecting some of the relevant empirical information that we possess. So we call it, we're forgetting it. Maybe we do, maybe we forget it on purpose. Maybe we don't want to draw that conclusion, say. Forgetful induction. So we forget it. And conclusion and generalization, we may speak of fallacy of forgetful generalization. We neglect some of the relevant information. I think some of the atheists have neglected the relevant information toward that proves a creation, that proves that creation had to occur. But you see, creation can't be verified by science. It's a matter of faith, and of course, they tried to define faith out of the picture. See, that's what we dealt with earlier. The second mistake is, of course, leaping to a conclusion. That's hasty induction or hasty generalization if you're drawing a generalization from it. So you're too quick. You don't have enough evidence, but you draw this conclusion. Again, if you're dishonest, you may do that. You may be wanting to prove something, and so you just grab a few pieces of information, say that proves it. But you haven't taken a good look at it. If you get into statistics, there's problems with misusing or using the wrong kind of statistics, a statistical approach or program. I did statistics almost before calculators, of course, and then I did it with computers later. I've had 18 semester hours of statistics, but when I did, I started out with just a slide rule and basic arithmetic, and that got pretty hairy for a while there. We had to use tables and everything else, and then I went to a calculator, and then I went to a computer. I've done classes with all of those. And of course, they got very sophisticated programs for computers that can get you statistical analysis of things. But you got to choose the right program, the right analysis technique. And you need to know how to choose the right technique, because you choose the wrong technique and it might not give you good information. So that second is hasty induction. You just don't have enough evidence, or your evidence is not good. It's not representative. You could go in and, for instance, whenever the election was going on between, I think it was between Dewey and it probably was Dewey running for president of the United States, and I think he ran against Harry Truman, but I can't remember. But Dewey, when he ran, they got on the phone and called people and they concluded he was going to win. But he didn't win because the thing was the people that were going to vote for his opponent didn't have telephones. See? So their sampling was not accurate. They didn't sample a representative group of the people that would be voting. And so that's very important that you take a sample of the that will be representative of the whole population. The third mistake is treating a conclusion as though it's less probable than it is. Now, he goes on and says, if a conclusion is something that for one reason or another we would prefer not to believe, all too often we refuse to accept it even after the evidence is piled up strongly. We persist in believing conclusions improbable when it's not. And again, all of these could get into our honesty, our fairness. And sometimes people are just lazy. They don't go through and do all the work necessary to get a good conclusion. And sometimes they have an axe to grind, and so they're trying to draw some conclusion, one conclusion or another. We have a hasty generalization, also called converse accident. And this, according to Fowler and Aaron, is an assertion based on too little evidence, not sufficient evidence, or the evidence is unrepresentative, as I noted in the presidential election, where I think it was Truman and Dewey were running against one another. And they used telephone to survey the people. Well, the people that were going to vote for Harry Truman didn't have telephones, a lot of them didn't. So they didn't sample them, didn't get a good sample. It wasn't representative of the total population that was going to vote. So they jumped to a conclusion that was false. They even printed in the newspaper that Dewey had won. And the newspapers called it early because they used the telephone. Now, a variation of the hasty generalization is an absolute statement. See, all have done this. And the words all, always, never, and no one that don't allow any exceptions. All have sinned, see. And so we see this in Romans. Well, all means the Jews and Gentiles. But Jesus didn't sin, and those below the age of accountability haven't sinned, see. So you need to be very careful with the word all and every and always. And there may be exceptions to it. Rarely can evidence support such terms, he tells us. So you need to be careful to using those terms. When someone uses it, it can be a problem. Of course, a stereotype. We stereotype groups of people. This group, that group, and we may have racial stereotypes or stereotypes of people's socioeconomic groups or whatever. And that's a form of hasty generalization. We have the reductive fallacy. It oversimplifies something. And so it's linking two events that as if one caused the other, and there one preceded another went before it, but it didn't necessarily cause it. Let me illustrate this. The illustration is very simple, and I've heard this a number of times by people say, well, poverty causes crime, does it? What's the evidence for it? If poverty causes crime, why do people who are not poor commit crimes? Rich people commit crimes. Why is it that all poor people don't commit crimes, see? And so there's two arguments against it right there. And so the idea of poverty causes crime, it may be a factor in crime. People get hungry and they steal to eat. But what we're saying is that poverty is not necessarily the total cause for crime. It may be a contributing factor. So that conclusion is not necessarily true, okay? Related to the reductive fallacy, the assumption that A preceded B, and A must have caused B. Black cat went across the road in front of me and I had a car wreck. Well, I'm so superstitious that I swerved to miss that black cat. and to get around him and keep him from going in front of me, that I would hit a light pole. Well, it was me that caused it, say, not necessarily the black cat. And so superstitions fall in this category, and it's called the post hoc fallacy. Hurley gives us another inductive fallacy, which we've already looked at before, but this is an appeal to authority, argumentum ad verecundiam. And he goes back and he says appeal to authority is an appeal, it's an inductive argument. Now, here he tells us it's an inductive argument, or here cites the authority or testimony of another person to support some conclusion. See, you don't have a universal truth there. You have the opinion or the words of someone. And it becomes fallacious to appeal to an authority if the authority is not trustworthy. Now, when trustworthy, I'm not saying he's dishonest necessarily. He may not have the requisite expertise to do something. Some baseball player, professional baseball or basketball or football player, he endorses something. Well, what does his endorsement mean? He may not know anything about this medicine that he's wanting you to take, this stuff that's supposed to help you feel better or whatever, or the particular clothing. He may not be an expert in this field, but because he's famous, he gets to be on a commercial, say. So commercials are that way. They'll pick someone that's appealing, say. And he may not have the expertise to be an expert in the field. And when people from Hollywood and people that are professional sports people endorse politically, that doesn't mean anything, because they're just like everybody else. They're not experts in this, the principles and what's going on and going to go on in politics. They're just giving you their opinion. They might be biased or prejudiced. They might have a motive to lie or disseminate misinformation. Somebody might. So if a person is biased or prejudiced, doesn't have the expertise, he has a motive to disseminate misinformation, to lie, or he might lack the requisite ability to perceive or recall. He might not be all there mentally. See, these are the things that would make an appeal to an authority, would make it a fallacious argument. It'd be unsound because he's not trustworthy for these reasons. Not that he's necessarily dishonest. He just may not have the knowledge, the background to be able to analyze something, to endorse it. The testimony of the apostles, however, and other witnesses of the Lord's resurrection, they have the ability to perceive and recall. First of all, these witnesses were there. They saw and heard and handled him. You can go back and see all of this. And they didn't have a reason to be lying because they were ostracized by society. They were abused. They were imprisoned, beaten, and finally killed. And this would be a disincentive to lying about Jesus' resurrection. We won't go into it any further, but they had the credentials. They had the ability to perceive and recall. And of course, the Holy Spirit caused them to recall. And then other questions. Into analogies, as I said, I thought we would. Analogies are interesting. Not all arguments are deductive, as Copey tells us. And one of the arguments that's not deductive, inductive is, of course, analogies. So we have conclusions that are probably true. It's inductive. Right? So used argument is an argument by analogy. Most of everyday inferences are by analogy. People use analogies to prove things and to make arguments. None of these arguments is certain, he tells us. pages 377 and 379. You notice the three dots. That'll quote. I went down and got some more information. So you really need to read the book to get the full context of it. But I don't think I've left them out of context. None of these arguments is certain, and they talk about analogies and are demonstratively valid. Demonstratively valid. And validity, remember, relates only to deductive arguments. So these are inductive, so they won't be valid. They can be cogent, however, have more evidence to support them, this idea. So none of the conclusions follow with logical necessity from the premises. But he says no argument by analogy is intended to be mathematically certain. Analogical arguments are not classified as either valid or invalid. Probability is always linked with them. The probability may be higher or lower, depending on the strength of the argument. Now, he tells us that between two or more entities is to indicate one or more respects in which they're similar. So you draw a number of respects in which they're similar. And so the similarity between two different things may not necessarily mean that the two things are going to be like in other areas, however. So you need to be very careful of that. Analogies are sometimes used to explain things or describe things, but we're not going to use them and discuss explanatory and descriptive analyses in this volume. If you want to do that, you need to get some other books that will deal with that. That's outside the realm of what I wanted to do. Now, analogical reasoning, we look at it, and this is Hurley. He tells us his reason depends on a comparison of instances. So you need to be sure that they're sufficiently similar if you're going to compare them. Now here's a simple argument about analogy. Entity A could be anything, has attributes A, B, C, and Z. And he says, and we find entity B has attributes A, B, and C. Now, what is the conclusion from analogy? Well, because you had the first three the same, both entity A and B had A, B, and C, and we then say probably B has the attribute Z also. Now, how strong is that probability? Well, it depends on other factors. See, that gets into the problem for us. Barker deals with it, and he gives us Hurley. This is Hurley, page 450. But scientists frequently make arguments from analogies. It's very common. Inductive analogy, according to Barker, is A, B, and C each observed to be S and P. Now, the two here I've chosen because they approach it from a different standpoint. And so there's a difference in their argument, how they're arguing here, how the analogy is set up. So I wanted you to see two different kinds. A, B, and C, each have been observed to be S and P, both S and P. D is an S, therefore D probably is a P. Okay. So that's pretty close to the one Hurley gave on page 450 of Hurley. But the form of this reason is close again to an inductive generalization. But the difference here is that the conclusion is a singular sentence rather than a universal proposition. That's the difference. See, we've got a single sentence, we got a singular, not a universal proposition. Hope you see the difference. That's the difference. Yes, that's what an analogy does. Martin and Owen, and that's a real good book. If you can find that book, I would advise you to buy it. It's very readable, and could be very useful to someone preaching and teaching the Word of God. The fact that two things, situations, sets of events, and so forth, are likely to alike in some respects. does not necessarily mean it's going to be like in all respects, other respects. So analogical proofs are not valid. See, we don't talk about validity, yet they can be cogent. And so they, particularly when the two things compare to the same general sort. So if the areas in which they're like one another are in the same category, or it's sufficiently strong, then we might draw a conclusion from it. That's more probability. The analogies are used in three different ways here. There are other ways they're used, but to predict further similarities. See, entities A and B both have characteristics X, Y, Z. And so probably both have, if the one has X, Y, Z and another characteristic, then the other one probably has that characteristic too. Again, we talk about cogency with inductive reasoning. Validity goes with deductive reasoning. So we can expose a fallacy sometimes with it too. I've analyzed in my Role of Women book some arguments by analogy were made by a man in a debate on the Role of Women. And his analogies were flawed. I showed his flaws. So the third use can be established a classification where scientists might use that. See, they might say, well, here's something. We find this animal suckles its young with a mammary glands, and so it's a mammal. And we come over here and we say, well, most mammals give live birth to their babies. Well, we come over here and find there's a couple of things that suckle their young with mammary glands, but they don't give live births. They lay eggs. Platypus. I think in Kenya, I think there's two animals in Australia that do that. So, Echidna, I think is what it's called. But anyhow, they lay eggs. Okay, so things are different there. Right? And so we draw different ways of classifying it. We may classify an animal that has its babies, it's a mammal, but the babies live in a pouch. That would be marsupials. They classify them, so they put them in classifications here by virtue of the characteristics. And so they classify things that way. Now remember, validity relates to deductive, cogency relates to inductive arguments. Now, Kolbe wrote regarding this, no argument of analogy is ever valid in the sense of having a conclusion follow from its premises with logical necessities. It's not a necessary inference. Some are more cogent and they have stronger probabilities. They're prized as establishing a conclusion more or less probable. Right? And he gives several criteria for it to say that it's a good argument from analogy. Here's 4 criteria. The first criterion relevant to the appraisal of an analogical argument is the number of entities between which the analogies are said to hold. If you got 10 or 15 things, areas where they're the same, then the likelihood is the 11th one, 15 of them, let's say, the 16th is probably going to be true. Your strength, the more areas where they have the same characteristics, the stronger your evidence is. So again, you're dealing with an amount of evidence. The greater the evidence, the greater the number of them, the stronger your cogency is. The second criterion for appraising is the number of respects which is followed or said to be analogous. That's what I just gave. So we have the number of entities between which the analogy is said to hold, and so the number of respects in which the things involved are said to be analogous. And the third is which analogical arguments may be prejudiced the strength of their conclusions relative to their premises. Again, this gets into a little bit of a problem here. Some of these are kind of fuzzy. How strong is it? How do you determine whether that is strong, say? The fourth criterion is that there's disanalogies, areas where they're not the same. And so points of difference. How do you explain them? And how are they dealt with? You got to deal with them, say. False analogy is one that supposes or insists there's a relevant connection when none in fact exists. I will give an illustration of this. In the Lord's Church, we've had some that have argued that Bible classes are parallel to the Missionary Society. Well, I believe the Missionary Society sets up a denominational structure, whereas the church has local autonomy. And so Missionary Society began to be the tail that wagged the dog, if you know what I mean. And this was set up around the time of the American Civil War, around 1860. It was one set up. It didn't last for a while, very long. Then they set up another one about 10 years later. So this is something that I believe is wrong. The Missionary Society is. So, but Bible classes, are they a parallel? See, that's the question. Claiming they're a parallel doesn't necessarily prove they're wrong. Just claiming it, you need to prove it. And some have argued that preachers, located preachers, at a church that has elders shouldn't have a located preacher. The elders ought to do the preaching. And so that's, of course, they claim it's a parallel to the Missionary Society again. And then I've heard some argue that multiple cups. Those that think we ought to just have one cup in the Lord's Supper, they make this argument that it's a parallel to missionaries, and I don't see how it's a parallel. So they're using an analogy to prove something, and of course, analogy doesn't prove anything anyhow. But I don't even think their arguments are cogent. I don't think there's any strength in the argument. And so, how are they parallel is the question. Can you show they're parallel? Right? The fallacy of pressing an analogy too far, okay, and extending an analogy beyond its actual reach, even when a connection does exist. Now, I've seen this with parables, okay. Parable of the tares has been used by some in Matthew 13, 24 through 30 and 36 through 43. Jesus discusses it 6 verses later. And they claim that proves because you can't bind up the tares, you can't uproot them, see. And I deal with the tares in my revised Great Commission book. And so if you don't have that, you be sure and let me know and I'll send it to you, electronic copy. I added up an appendix on the parable of the tares. But they claim it prohibits church discipline, see. And I don't believe it does. I don't believe it's talking about that. So, but there's other parables that people get into. And the parable of the prodigal son. And so they will make it be something that's not. I think the prodigal son is actually the people in the context are those that were the Pharisees were condemning Jesus for associating with sinners, publicans, and people like that. And Jesus was not partaking of the sins of these people. He was trying to convince them and to influence them to turn away from their sins and repent, come back to God and obey God. So the prodigal son, I believe, was those people that Jesus was associating with, and the elder brother was the Pharisees, and the father is God. That's how I interpret the parable. Again, parables are sometimes they use analogies to draw around conclusions. And of course, a weak analogy is one that doesn't have very much strength in it to prove it, see? So it's weak. And an analogy, again, doesn't prove anything anyhow. It just shows the probability if it's a strong argument, a strong analogy. Weak analogy proves nothing. Sometimes a good way, Barker tells us, and this is kind of important to remember. I want to read it. Good way of showing that it is weak is to show that the available evidence permits us to construct other arguments by analogy. They're no weaker than that, but they reach an opposite conclusion. So take the same points, draw an analogy to show that it would show something the opposite. It would show contradictory conclusion. In other words, if they're claiming it's an A-type, all you got to do is show that by analogy that you can draw the conclusion that it's not an A-type, that you could have the contradictory, there'll be an O-type, or you could have a contrary conclusion to prove it by analogy, and that would be an E-type. So if they are trying to claim an A-type proposition, you can go to square proposition, you can do the contradictory, that would be an O-type, or you could prove an E-type, and that would say both E and A cannot be true. They can both be false. Remember, they're contrary to one another. Now, Bruton, Peterson, et al., and they deal with this. I don't know. Let me look down here. I'll see if I got time to go through it. Yes, let me go through this down to the next heading, and then we'll stop. I thought I'd get that far. Analogy, again, Peterson, Bruton and Peterson. Now, this is a high school, probably sophomore level or somewhere thereabouts, high school English grammar book that was used back around 1965 or somewhere around 1960. Analogy, that's a long time ago, and about 60 years ago. But it's still true. And they say analogy is a type of inductive reasoning based on the idea that two things compared are found to be alike in a number of important characteristics. Analogy is a comparison made between things that are really not similar. And when you come across a suspicious analogy in your reading, he said, they tell us whether you think it's deliberate or not. Ask yourself these two questions. Here are the two questions. First, are the things compared really similar in a number of important characteristics? Second, are the differences in the things compared great enough to invalidate the comparison? Are there differences? If there are differences, would it invalidate it? Let me point out, there was a debate between Robin Haley and another man, and on the question of whether or not we could use women translators in the assembly of the church for translation. And I believe Robin was taking the right position. I didn't agree with every little argument that Robin made, but I think by and large he did a good job. But what we get into here is the man that he was debating, he made the argument regarding a judge could use a translator in his courtroom. And the problem with this is the analogy breaks down, and I showed in my Older Women book that it breaks down. Bob Berard was making this argument against Robin Haley. And Bob Berard has passed away. He's been dead several years. But Robin was advocating the truth. But Bob Berard argued that a judge could use a translator, man or woman translator. Well, the problem with it is the judge, he has different rules for what's going to go in his courtroom than what goes on in the church. And so, yes, a woman can get up and be a judge even, but she can't be a preacher in the church. So they're not parallel to one another. Does that make sense what I'm saying? Anybody out there? In the combined book, I discuss that down here in pages 583 and 588 through 590. That's regarding that debate between Robin Haley and the man he debated, okay, Bob Berard. All right, here's some areas where analogies came in. I discuss them. 2000 is the Flood Book, the second edition, page 307, 367. 2003 is my Work of the Holy Spirit, Volume 1. Here's a number of pages. 2005 is Work of the Holy Spirit, Volume 2. Right? Let's look at inductive arguments becoming deductive next week. This is really where now we're going to be able to use induction. We're going to actually use induction, and it's going to be very valuable for us to use in drawing conclusions from the scriptures. And we'll show you how we can use it, and it becomes a good method to interpret the Bible. So this will get into interpretation of the Bible, but we've got to lay our groundwork first. So we'll start with this next week. Are there any questions?